Right, so we're going to talk about the project, right, for this class that is dealing when in 3 weeks, I guess. All right. So let's talk about the date now. Then we're not confusing like before, like we. So last time, what did you show me last time? Yeah, I think it's about that 18. So you already passed 1 week, 2 weeks. October 15, 16. Okay, October 16. So we talk about final project, right? The second part, right? All right, so let's send an announcement. So for A2, okay? All right. So due by October 16, okay? Now, any other question about the due dates or what we expected? We could talk about that. So, go to final project, right? So we already created user interface. Now we can switch out your Java data structure, like array list, if you use that. Now we're going to implement our own structure based on the concept that we learned. Right, we have learned set, list, map, right? Stack, queues, and we're not gonna use array list like or set a linked list from Java API. We're gonna implement our own, and our own required to have the operations that we identify here: add, set, remove, index of, contains, empty size, get, toString, reset, get next, has next. These are the iterators when you iterate to a list. So if you want to get more definitions, you can always look at the iterator class in Java. What has next? Okay, what's next? Okay. Now, you also need to follow the requirements. So first is unbounded. What does it mean? If you use, how would you create one, right? Technically, you're not allowed to use array list anymore. And I show you to create one. You either use linked list or pretty much you create your own linked list too, right? Or use an array. When using an array, it's bounded by the size of array because you have to declare the size. My array has to specify the size. Unless you want to implement a dynamic array, which you could, by whenever you add, it's going to put into the array, you keep tracking the size, right? Now we have if statement. If the size equals to the size of the array, when you increase the size of the list, right? Then you could create a new array with a bigger size. Remember we were looking at the one from the Java collections when they have the coefficients, or they call factor. No, they call factor, like they use 0.75. You guys still remember? That is pretty much the factor when it's full. That is going to increase the size by 75% from original. Like for example, if your size is 100, right? Original array size, we talk about using array, right? And then the size of the user happen to be reaching 100, then the array is full. Then you're going to create another array, which is a bigger size. If I pass the factor at 75%, it's going to be 175. And then you just copy the old array to the new array, and then you just insert it. Next element, 101. Pretty much your program just enlarging itself, right? That is unbounded one way. Another way, just use linked list is always unbounded already because it always add to n, right? I think we were looking at when we talk about map and set, right? It's chapter 21. Yeah, it has a factor that you, when you create a constructor, it's called that. Here, load factor, initial capacity, see that? And you can provide the load factor. Okay. We talked about this already, so I'll let you go back and review. You need to see what load factor means. But this is just what I went to. If you implement your own, right? Just use that load factor. So now come to the. So we talk about unbounded requirements. So let's talk about second, do not allow duplicate elements on our list. Okay. So when we were talking about set, it looks like if we use set, it's already talk about not allowing, I mean, for non-duplicate, right? Non-duplicate elements, yeah. It's more efficient, right, to use set. So you may consider to implement set in this case, right? Oh, we have to use exceptions. So everyone understand what's exceptions? You have learned that in 201 or not? Okay. So yeah, you require to use exceptions. Now, what is exceptions? You could review exceptions in Java. So there's a superclass exception is in chapter 12, right? Superclass, you already know the concept of inheritance. So superclass of exception is exception, which I mean itself is object, and then we have durable. We have exception itself, right? And when you run the program, you're gonna see like class left exception, IO exception, runtime exception. You get all the errors all the time when you compile your program, right? It's coming from the exception. Like null pointer exception, you may see that, right? So when you run your program, normally you get that type of exception. But when you compile, you see like class not found exception, IO exception. But when you run, it's under runtime exception. So it's error at runtime like arithmetic exception. When you try to divide by 0, you get that exception thrown out. Right? As an error message. Error message pretty much exceptions. So why do we need exceptions? So then you know what the error in your program, right? Then you can go and fix the errors, right? If there's no exception, then you don't know what happens. But they just categorize it into different categories, yeah, right? Like index outbound. So as you see index outbound, you know it's about race, right? That you try to refer to index as not valid, right? Like when you see null pointer exception, you refer to an object that is null. It's not never instantiated. It's never created. This is deal with the add, subtract, divide, or the arithmetic operations exception. And we have the I/O when you try to read and write to the file, it's not existing. Class, you don't even have class. That class not existing. That's maybe you missing the library. Right, class not found exception. We have errors. So this pretty much main exceptions. Hmm? Oh, you have to create your own exceptions to handle in your data structure. Like, for example, you have to handle when you try to remove, and if your set is empty, how would you remove? It should throw exception. Say the set is empty. Right? You have to say cannot remove because there's nothing to remove. All contains when you search, right? Right, remove like is empty, remove get and contains must check for the list is empty or not. This is just an example. Now, how to write, right?
The class not found exception is like that the single zero is kind of like that, right? Because when you're trying to access a code, a method of other class, if you can't find it, it's like it's become red. So that is class not found exception.
Like when you don't have a class, you try to use the class.
Yeah, so it's become red. So that is the class not found exception, right?
I don't remember. Yeah, I mean normally errors is red. Yeah, yeah, it's red. Yeah, the text is red. Mm-hmm. So, I mean, if you want to review exception, it's basically just like if else first. If you look at it, start to deduce you from the basic like when you try to divide by 0, divisor cannot be 0. You just check like the denominator is number 2 should not be equal to 0. Then you allow, or you just print the message out. Alright, so now look at a better version of this. We just move it into the method. So main is going to call the quotient, and the quotient just do the same. Right? Now, if we're improving this a little bit using exceptions, so the method itself, like I said, if you want to do the like add, remove, you should start to check if the number that is provided equal to 0. So in your program, if I say add here, right, or remove, okay, then you should say is if the list is empty. If it's empty, you should throw. Like this is if the number is 0, then you should throw arithmetic exception. Divisor cannot be 0. Okay. And if it's not 0, it's pretty much just execute this line of code, like 8, and then returns. Now, you have to understand how to use exception, right? So, exception, you could throw, like in this case, we throw statement for the quotient, and the quotient is the method, right? Throw statement is pretty much just like system.out, right? But you just throw to the class arithmetic exception. The one who uses quotient is the main method. The main is going to try to divide by calling quotient. If there's no problem, then it's going to print a result. But if it happens to be equal to 0, so this guy is going to throw, and this guy is going to catch exception and print out the message. Right? Cannot divide by 0. And this is the type of exception that's catch. Arithmetic exception. So we have to use try and catch. And the method itself is going to throw. Okay. So the value thrown, like in this case, the new arithmetic exception, we call an exception. The execution of a throw statement is called throwing an exception. The exception is an object. Right when you throw, we create a new object of the arithmetic exception from exception class. Right. Like in this case, it's arithmetic exception class. And the constructor of arithmetic exception class just take the string message. Like divisor cannot be 0, which is a string. Now when the exception is thrown, the normal execution flow is interrupted. Right, when it's thrown, then it's interrupted. It's going to pass exception from one place to another. This statement for invoking the method is contained. So since the method is thrown, then the statement should invoke. When you use the method, you should invoke with try and catch. Okay. And if there's an error, it's going to handle in a catch block. So the throw statement is analogous to a method call. Instead of calling a method, it calls a catch block. Like in this case, the catch block is like a method definition with a parameter that matches the type of the value being thrown. So if you look at this, right, we have try to run the code, a statement or a method that may throw an exception, like in this case, the quotient method, right? And you still be able to run the code as usual if there's no problem here, more code to run. But when there's a problem with this statement, then it's just going to stop doing the following statement, and then it's just jump to catch, and then process what you want it to do. It doesn't have to print out. It could be try to do something else, right? This is just print out a message when there's an error. Like when you use Windows, when you happen to do something, then Microsoft pop up say you want to send a report. So that's pretty much the catch statement, right? And then the program still run after you hit OK or cancel. So that's the point of using try and catch. If you're not using, then if there's an error, your program just crash or freeze, which is not good, right? So that's why using try catch is better to handle. Like imagine that if I create a list and the list is full, right? Using array, I try to add into the list. Then that tab is going to throw. What type of exception is going to throw?
What happens again?
When the array is full and you try to add, it should be index out of bounds, right? Because it's increment index, right? But when you run the program, you don't see it because it's actually in your console, right? That print out. Then the user is gonna, you're not gonna know what happens. The program just freezes at that point. Then you should do try catch to handle. Then it's going to at least pop up the message, right, to notify the user, hey, because it's full, right? Or at that point, you can actually handle by call enlarge to increase the size, right? If you don't want to, right? To notify user, you can enlarge the size or whatever, right? Then the program not interrupt, right? It still be running. So that's the point of using try and catch. Make sense? So that pretty much you need to implement. So I just talk about exception types. Like exception also have types, it's just categorize them. Right. So the illegal argument exception, a method is passed an argument that is illegal or inappropriate. Then you get that one. So we talk about pretty much, we explain each of these exceptions. So what's the throwable then? Throwable pretty much is a root, right, of exception classes. All Java exception classes inherit directly or indirectly from the throwable. Now, if you want, like I said, you have to create your own exception classes. When you create your own exception classes, you can extend exception or even a subclass of exception. It depends on the category that you fall into, right? Or you can just extend exception. So let's look at how we're going to create our own. And let's look at more on exceptions too. If you look at this, so it say Java exception handling is based on 3 operations: declaring an exception, throwing an exception, and catching an exception. So before, when you see quotient, it didn't declare, right? You should declare an exception, like throws exception. That's how we declare on the method. And then that means you have to check exception in this method and throw an exception when there's an error, right? Just like if there's an exception, you just throw it. And then lastly, the one who used the method that has declare exception, it needs to surrounding with try and catch to handle the exception. And this is process to handle when there's an exception when you invoke with this method.
Where would it print? It wouldn't print on the Java FX applet, would it? It would print on the bottom part of the screen.
Yeah, it depends on how you want it to print, right? It can be pop-up box if you use the option pane.
So you could set up for the exception to throw up a pop-up box.
It's right here, right? Catch. Catch is how you want to handle it. You could do system.out.print, that's print on the console. You could do the option pane, that show dialog, right? Show. Let's print on. It doesn't have to print to if you not handle to print. So under the handling is the one who this depends on the programmer or the logic of the application, how you want to handle it. Like most likely, like in the application, it's going to be in the log file. It's not print on the console either, because when the application running, it's going to log into the file, just like write to the file. And then, like Microsoft said, you want to send an error report, you pretty much just send that file, right? Because no one really monitoring the console. That's why they have to keep writing the log, and then you can look back, right, what caused the errors. So the answer is most likely in the log file. So now to declare exception, you just add those statement to the method name, right? And to throw exception, you just inside just create a new exception to throw. So this one pretty much is the same thing as we do here. This is instantiate an object, and then throw the object name ex, which is we prefer just do it once because we don't really use that object anymore. That's why we just shorten it to new, right? We're not going to use ex anymore. We just throw it. Okay. So that's more preferable way to write. And to catch, so we're going to surrounding the statement, which is the one that we throw the exception with the try block, and then surrounding the handling with the catch. So the handler like exception can be more than one, like because you can declare more than one exception inside the method. Like you can just say IO exception, comma, class not found exception, comma, arithmetic exception. So because in one method you may be able to handle several exceptions. So that's why we have multiple catch here. You can catch several exceptions too. Now, so this is pretty much just using a stack as application too. So we said example, right? Main method, try to use method 1. And the method 1 try to use method 2. So method 2 has been to be if you see that there's a chain of method using here. And method 2 has like try to use method 3. Now the one who really throw exception is method 3, not the method 2, not the method 1. Right? The one who really throw exception is method 3. But method 2 use method 3 and method 1 use method 2 and main method use method 1. In this case, you have to surround with try catch, right, for all of them, right? And that's why we have a stack called, we just keep pushing main method, method 1, method 2, and method 3. If an exception is not caught, so the process is repeated until exception is caught or passed to a main method. So if there's an exception caught, so it's going to start to caught. So it's pretty much just depends on which level it's caught, right? If it's caught at method 2, then it's going to throw here and handle, throw right there and handle right here. So it just depends on where it's going to get caught, right? And handle. But whenever it's thrown, you have to use that for all of them. So the order in which exceptions are specified in cache block is important. A compile error will result if a cache block for a superclass type appears before a cache block for a subclass type. For example, in the next page, errorless because runtime exception is subclass. Okay, so now you remember that since we can handle multiple cache, right? We know that I show you the hierarchy, right? Runtime exception extend from exception. Then you can put exception before. Because if you put exception before, it will never reach runtime exception. Right? Because exception is a superclass of all the exceptions. So that's why the order is important. You should get the subclass first. Like in the case that runtime exception cannot handle, then you just do exception for general exceptions. Right? If you happen to put this, it will never reach this because it's going to handle everything because that's a superclass. So the order has to be like that. Subclass first. So it says Java forces you to deal with checked exception if a method declares a checked exception, which is an exception other than error and runtime exception. So you must invoke it in a try-catch block or declare to throw the exception in a calling method. For example, method P1 invokes method P2 and P2 may throw a check exception. You have to write code as shown in A or B in order to pass the compiler checking. So let's look at, you guys use the IO exception before? Like when you write and read the file. So what happened? How do you read and write the file? Right. So, I mean, you could use scanner too, you know, right? Like system dot. When you use scanner, the constructor is file, right? File source, see that? When you try to read in from the file, right? You see it's declare exception right there. So file not found exception. This is called we declare exception. So that means it's what happens if you use scanner like this one? Since the method declares a checked exception, so checked exception pretty much any other exception that are not, those are not error or runtime exception. Because runtime exception we cannot handle until runtime, right? So like we talk about there's subclasses on runtime exception, right? Like index outbound exception. We pretty much cannot check. But this is file not found exception. Is it runtime? Let's see. It's a file not found exception. It's under durable exception and IO. So it's not under runtime. If you remember the hierarchy, right? Let me just go back and show you one more time. Here, right? Runtime IO is not under runtime, right? Class not file is under IO, right? So meaning that this is a checked exception. Like scanner has file not found exception and file not found is the checked exception. So you must invoke a try catch. Okay, let's see. Is that true? Let's test. So I'm going to create a scanner, right? Object, and read from the file. Scanner scan equals to new. So this has to be file, which is new. You can create object on a file, right? Say test.txt. So this is for reading the text file, right? And we import that. Now let's do an errors. Because it's a checked exception. Remember, if you do system.in, there's no errors. Right? It's fine now, right? Because it's not checked exception. Why? Let's go back to the Java doc again. For the scanner, if I do the file, it's declared the checked exception. This is called checked exception. But if I do the system.in, string source right there, there's no declare exceptions. Or system.in could be the system. Scanner has multiple constructors. Let's just go to the top. The summary of the constructor. Input string right there. Because it can read from string. So input string doesn't declare exception. See that? But this guy happened to use the constructor that's declare the checked exception name what? File not found exception. So I'm going to create a new file, right? There's an error. Why? Because according to this, it say you must invoke it in a try catch block or declare to throw the exception either this way or this way. So if I do this way, this is my method P1, right? Just like main. I have to do throw. What's the exception? File not found exception. Then it's happy. So that's what I mean. Why is checked exception? Okay. Or you have to surround it, right? I'm using this method, right? I have to surround it in try. I want to try to find a new file, right? In case not found, it's going to throw the exception, right? I mean, because the constructor asks us to throw already. But I have to handle file not found exception. And I have to handle that. And I have to import this part of java.io. And then it's happy. It's required you to handle. Or you can, if you don't handle, you can keep throwing again. It's just like the method 1, method 2, and the method 3. If they're not handled, try. You can just throw. Right. Just declare the exceptions. Now, this technically you could handle system dot error. It's just print in the rate, right? File does not exist. System.error thing, right? Now you run it should handle exception by no longer print out the error message, but handle by just print. That they have the errors. System that errors. Yeah. They should print file doesn't exist. Right there. Right. Because there's no such test.txt. Now if I create a test.txt. Alright, just let's try to run again. Okay, so I said text.txt, that's why. Refactor, rename. Okay, no more errors, right? So that's how the type cache works, right? This is how you use it. You didn't create your own yet, but you understand how to use other type cache of those. You can do multiple cache in this way too, instead of type cache. You can do cache or exception like that too. An exception itself has the method that you can get information from it. Right? Like if there's an error, besides printing like that, you can just also print the method. Like Princeton Traits. Right, so you guys say, what's that? It's going to print the throwable object and it's called stack trace information on the console. Pretty much just like when you see the error when you run program, you see error. You have to trace back where the program starts to get an error. That's pretty much a stack trace, which we like to print that on the log. Then when user do something, developer can just go in and read the error code. Just like you've been reading the error code to fix the problem. Right? Same thing. Then they know how to fix the problem, otherwise we don't know. So that's why we like to log that too. So that's just commonly used print stack traits. Like that, that's the print stack traits. You've seen it before, like index outbound. Like you try to refer to index 5 at that line of code. Right. Then you can just go back and look at the code, fix the errors. Alright, so this is just another example. So this just show you the complete set declaring, doing, and handling, circle with exception, and the throw it here, throw it here. So this is to declare, right? In the method headers, and this is the actual throw, right? So to declare, we use throws with the S. When you throw, you say throw. Okay. So now we see this example. I guess we need to know how to create our own exception. Oh, before that, the try catch also have finally. So finally clause is always executed regardless whether an exception occurred or not. Like you can do try catch and then finally at the end. So normally when there's a problem with statement, it's going to stop doing the rest of the statement in that try block. It's going to catch. Now finally mean what will happen if there's no errors or errors is still going to do finally. Like what you want to do next is going to go there. When to use exceptions, whenever the method is going to create an errors, you should handle it. Java allows exception to be retold, just like we do main and retolls again. If the handler cannot process exception, or just want to notify the exception. So this is just a chain of exception. Alright, so this is how you create your own exception class. So you technically can create a class that extends the exception, right? Then it becomes an exception. Like in this case, the program want to create a circle. The radius is supposed to be positive number. Now, if the user provide the negative numbers to create, then you should throw exception. By creating the invalid radius exception, and then in the program itself, in the class itself, you have one radius as the attributes. The constructor just take the radius. Now, since it's extend exception, we call the super to pass in pretty much just the string message, right? To override, the method of the super class. And then you just set the radius, and you have get radius. So that's pretty much it. Like the exception itself should be very simple. You can just call the super. Your constructor just pass the message to a super exception. And when you use, it's the same thing. Now you can just use your own exception, invalid radius exception. Right. So this one we throw on the method that you suspect that it could create an error. Like this should be an error because it's a constructor which it could initialize the values of negative, right? That's why you put those. And the set radius too. You just do the invalid radius exception too. And then this is when it's greater than or equal to 0, it's fine. Else, then you should throw exception. So that's it. This is just showing the file class demo that I showed you already. So if I want to create an exception, like for example, last time we have stack, right? So I have the stack. let's look at the CLL stack. So if I try to pop from an empty stack, this one I should create exception. Throws, right? Empty stack. I create my own exception, right? Exception. Looks like it's part of the Java util. Okay. Empty LL stack then. Then I'm just going to create a class extend exception. And then I'm going to create the methods like the constructor of this, right? That extend the super. That's how you create your own exception class, customize it. So the constructor should call the super of the exception, right? Like the constructor should get the message from the user when I create new, though I do new, empty of stack exception, right? I pass the message, so this should be string, right? And then I just pass that to the super class. And that should be it.
So in
Now, now when I use, right? Before I have to check. Let's import, right? If I have the method is empty, I don't have one. So let's create is empty. Because we don't want to pop from the empty list. How do you know if this is empty? This is linked list. Linked list, we use head, right? If head is equal to no, right? That means empty, correct? So we got to compare if head equals to no. If head equals to no, that's true. Right, so if it's empty, then we're going to throw new, and then we pass the message. The stack is empty. Now, let's see what. Oh, it happened to use from the library, right? We don't need it, that one. Now the interface, right? My interface is supposed to declare this too, because I have I stack. Okay. Then let's fix the problem. That's it. That's how you implement. Now, if I try to pop, if I test, let's say my stack is empty. Pop test, right? If I just do pop, this one happened to initialize, right? So if I don't initialize, I try to run this pop, it should send the message out, right? It should print the message. The stack is empty. Array is about exception. Oh, we're using array this one. Oh, because I was testing to compare to, and then I want to test our stack, right? Okay, let's just let the array run. It should still fail anyway, but we want to see this, right? The stack is empty. Form the exception that we just create. That makes sense now? So this is what I expect you to do, right? To create exceptions for like the operations on your project. So these are the operations. You have to think about which operation needs exception, right? When to use an exception when the method creates error. Like I try to remove from an empty list, or I try to add into the bounded array, bounded list. Okay. So let me edit the requirements a little bit because I want to create more into more general term now. So you just say handle exception, right? Like right? Like it's empty, remove get contains. Pretty much the same thing here, right? And then you have to do unit test, right? Unit test all of your operations, each of the operations. Now, and I need you test each operation, and you need you to explain why you choose to implement this type of data structure. Like if you implement set, why do you think set is appropriate to use for storing user data? You can say, because set, since we're going to create a non-duplicate list, we said set is more efficient for the non-duplicate, right? You can explain them a big O too, right? Flush operation. So in your test, you're gonna have to, each of the method that you create, the operation here, you should be able to identify its own big O. You can see, like, I'm gonna ask, like, pop, what's the big O of pop? But I will say, okay, I'm going to use linked list to implement pop. Now you have to know how to implement pop with linked list. And what's the big O of that? That's for example. And we use array to implement NQ. What's the big goal of that? Like you should know all the operations. I'm going to make linked list to implement order list. What's the big goal of that? So that's why it's a good idea that you start to implement your own operations now. That is going to be a question on the test, something like that. You should know pretty much all the big goals, efficiency of your code. So that's why you should start to explain here. Include Java doc, UML diagram. Okay. I think that's pretty much your project there. Let's look at the extracted part. You should be able to sort by more than one field. That's it. Now we only sort by username, right? I think that should be it for today. And I'll see you